Hey everyone, today we are going to solve the Daily LeetCode challenge of 6th April 2024 and the problem statement is minimum remove to make valid parentheses. So let us first understand the problem statement. So according to the problem statement, we have been given a string S such that it contains parentheses and lowercase English alphabets. Okay, so we can see that in this S we have opening closing brackets, correct? And we have all the English alphabets present in lowercase. Fine. Now what we have to do is we have to remove these parentheses in order to make it a valid parenthesis. Now what does a valid parenthesis means? So it means that for every opening bracket there must be a closing bracket, and similarly for every closing bracket there must be an opening bracket. So what do I mean by that? It means that, say for example, if we have been given a string something like this, okay, so we can see that we have an opening bracket, and for that opening bracket we have a closing bracket, correct? Similarly for this closing bracket there exists an opening bracket. Fine. Now if I'll ask you that is this a valid parenthesis, so you will say yes. Why? Because for this opening bracket this is the closing bracket, for this opening bracket this is the closing bracket, and for this opening bracket this is the closing bracket. Fine. Now if I'll ask you is this a valid parenthesis, you'll say no. Similarly, if I'll place an opening bracket over here, still you'll say that this is not a valid parenthesis. Why? Because for this closing bracket we don't have an opening bracket, correct? And similarly for this opening bracket we are not having any closing bracket, right? So this is not a valid parenthesis. So in the problem statement, the string which could be given to us can be an invalid parenthesis string. So what we have to do is we have to remove the parentheses which are leading it to be invalid, correct, in order to make it valid. And why is it mentioned that we have to remove minimum number of parentheses? Because let's say that this is the string given to us, correct? So what you will say is that we will delete all of the parentheses and we'll get an empty string. And you are correct. Why? Because an empty string is also a valid parenthesis string. So the answer would be right. But they have mentioned us that we have to remove minimum number of parentheses so that you don't do something like this, right? That is deleting all the parentheses. Fine. So what we will do is we will only delete those invalid parentheses. And what do I mean by invalid parentheses? We will delete only those parentheses which do not have a pair. That is, if there exists an opening bracket without a closing bracket, then we will delete it. Or if there exists a closing bracket without an opening bracket, then we will delete it, correct? Now, if we see in this particular example, then what we have? We can see that this is an opening bracket, and for this opening bracket, this is the closing bracket, correct? So this is a valid pair. But for this particular closing bracket, there is no opening bracket, right? So this one, because of this one, this string given to us is not a valid parenthesis string. So what we will do is we will remove this one, and what we will get this string, correct? So what we have to do is we have to remove minimum number of parentheses in order to make the given string a valid parenthesis string. And once we have made it a valid parenthesis string, we simply have to return that particular valid parenthesis string. Okay. Now let's see how we can solve this. So I'll be discussing three approaches. Let's first discuss the first approach. Okay. Before discussing the first approach, I would like to mention that if you are someone who has solved the LeetCode problem valid parenthesis, then I'll suggest you that give some more time to this problem and you'll be able to solve this on your own and you won't need to watch this video. Okay. And if you are someone who haven't solved this problem, then you might face a little bit of difficulty in solving this problem. So let's understand this, okay? But if you are someone who has solved this problem, then just observe this problem a little bit and you can solve this problem on your own, trust me, okay? So getting back to the question. So we know that this string S contains alphabets and it contains parentheses, okay? Now tell me that in order for this string to be a valid parenthesis string or to be an invalid parenthesis string, which of these two would be contributing? The answer is parenthesis. Why? Because it doesn't matter whether in this string the alphabet is present or not present and in which order they are present in, it doesn't matter. The only thing which will lead this string to be a valid parenthesis string or to be an invalid parenthesis string is the parenthesis, right? Correct. So what does it mean? It means that while solving this problem, we would be only worrying about the parenthesis and not the alphabets. So whenever we'll get an alphabet, we'll simply ignore it in the dry run, okay? So now let's discuss the approach one. So as we discussed that we don't care about the alphabets, right? So initially we will be present over here, that is at this letter L. And since we don't care about the alphabet, so what we'll do, we'll simply ignore it. So we are over here. So we have got an opening bracket, correct? We have an opening bracket. Now we'll move forward. This is an alphabet. We'll ignore it. We'll move forward. We have got a closing bracket. Now we can see that here is an opening bracket and this is a closing bracket. It means that we have got a pair of parentheses, right? Valid parentheses. So these two are valid. So we don't need to worry about them. Okay? Now we'll move forward. Now we have got a E, which is an alphabet, so we'll ignore it. Now we have got an opening bracket, fine. Then we'll move forward. We have got a letter. Since we don't need to worry about it, we'll ignore it. We have got C, so we will ignore it. We have got a closing bracket. Okay. Now what we can see is we had an opening bracket and we have got a closing bracket. Then what does it mean? It means that this is a valid pair of parentheses, so we don't need to worry about it. Now we'll move forward. We have got a closing bracket. We'll move forward. We have got a letter. We'll ignore it. We'll move forward. We have got an opening bracket. We'll move forward. We have got a D. We'll ignore it. We'll move forward. We have got an opening bracket. We'll move forward. We have got a E. We will ignore it. We'll move forward. We have got a closing bracket. So let's write it over here. So what we can see that this is an opening bracket and this is the closing bracket. So what does it mean? It means that this is a valid pair of parentheses, so we don't need to worry about them, correct? And what we will do is we'll simply move forward. Now you can see that we have clearly processed all the elements of this S, correct? Now let's see that what we got. We got that this is a valid pair of parentheses, this is a valid pair of parentheses, this is a valid pair of parentheses, correct? But these two are invalid parentheses. Why? Because for this particular closing bracket, we didn't found any opening bracket. Fine. And for this particular opening bracket, we didn't found any closing bracket in this string. So it means that these two are invalid parentheses. And because of these two parentheses, this given string is not a valid parenthesis string. So what we will do is we will remove these two parentheses in order to make this particular string a valid parenthesis string. So which are these two? We can see that this one is this one and this one is this one. So what we will do is we will remove these two. So if we will remove these two, what we will get, so we can clearly see now this particular string is a valid parenthesis string, correct? Why? Because for this opening bracket, we have this closing bracket. Similarly, for this opening bracket, there exists a closing bracket. For this opening bracket, there exists a closing bracket. So all the parentheses given over here are now valid. So we have converted this particular string to a valid parenthesis string, correct? Now, you might have noticed the pattern over here. So tell me that which data structure are we going to use in order to solve this problem, correct? So the answer to this would be stack. Why? Because what we were doing, we were adding an opening bracket and whenever we were getting a closing bracket, then what does it mean? It means that if there exists an opening bracket and we have got a closing bracket, it means that it's a valid pair. So we will simply remove it. Similarly, if we'll move forward, whenever we'll get an opening bracket, we will add it, and whenever we'll get a closing bracket and we will see that an opening bracket exists, it means that it's a valid pair and we will remove it, correct? Like whenever we used to solve the problem, valid parenthesis. So what we used to do, say for example, if this is the parenthesis given to us, if we will get an opening bracket, what we used to do, we used to put it in a stack. Then if we get an opening bracket again, we used to put it in a stack. Then again, we used to get an opening bracket, we used to put it in a stack. Now, when we'll get a closing bracket and we can see that this is an opening bracket, then what we'll do, we'll pop it, indicating that this is a valid pair. Then we'll move forward. We have got a closing bracket and this is an opening bracket. So what we will do, we'll pop it, indicating that these two are a valid pair. Then we'll move forward. We have again got a closing bracket and here is an opening bracket. So these two form a pair of valid parentheses. So we will remove it, correct? We used to do the same in valid parentheses. So we will use the similar kind of approach, but an extended version in order to solve this problem. So let's quickly discuss it. Now that we understood that we will be using stack in order to solve this problem, so let's see how we will use it exactly, okay? Now the question is, what would be the type of the stack? So the type of the stack would be pair of character, comma, integer. Now you may ask, why are we taking a pair of character and integer, correct? So for this character, what we will do is, we will store opening bracket and closing bracket. And for this integer, what we will store is, we will store the index. Now you might ask that, why do we need to store the index, correct? So the answer to this is that whatever brackets, that is whether an opening bracket or a closing bracket, whatever would be remaining in this particular stack at the end, that would indicate that it's a invalid parenthesis, correct? And we have to remove it, fine? So we know that it's an opening bracket, it's a closing bracket, and these two are the invalid parentheses, and we need to remove it. But in the question, that is in the given string, there exist multiple opening brackets and multiple closing brackets, right? So how are we going to know that which is this opening bracket and which is this closing bracket? So in order to know their position, we will be storing its index, correct? So let's start the dry run. So initially we would be present at the 0th index. So since this is a letter, we will ignore it. We are at the first index. We have got an opening bracket. So whenever we'll get an opening bracket, what we will do? We will push it in the stack. So we will push this opening bracket and its index. So what is the index? The index is 1. Okay. Now we will move forward. So we have got a letter. We will ignore it. Now we have got a closing bracket. Now the moment we will get a closing bracket, what we will do? we will check that is our stack empty. No, our stack is not empty. So if our stack is not empty, what we will do is we will check is the value present at the top of our stack an opening bracket. So this is an opening bracket. So what we will do is we will pop this. And why are we popping this? We are popping it so as to indicate that for this particular opening bracket, we have encountered a closing bracket. Correct. So these two are forming a valid pairs. So we don't need to put them in the stack. Why? Because in the stack, what we are storing? We are storing only the invalid parentheses, right? And since these two are a valid pair, so we don't need to store them in the stack. So we'll simply remove it from the stack. Then we'll move forward. We have got a letter, we will ignore it. We have got an opening bracket. Now what we will do is we will store this opening bracket and its index, that is 5. And we will move forward. Now we have got a letter, we'll ignore it. We have got a letter, we'll ignore it. We have got a closing bracket. Now what did I mention? I mentioned that whenever we will get a closing bracket, what we will do? We will check that does its opening bracket exist. So what is in the top of the stack? In the top of the stack, we have an opening bracket, correct? So what does it mean? It means that for this particular closing bracket, there exists an opening bracket. So what we will do? We will pop this, indicating that for this particular opening bracket, we have found a closing bracket. So what does it mean? It means that these two are forming a valid pair of parentheses. So we don't have to remove it, right? Now what we will do, we'll move forward. Now we have got a closing bracket. Now whenever we used to get a closing bracket, what we used to check? We used to first check whether our stack is empty or not. If our stack is not empty, then we used to check is the top value an opening bracket, correct? So firstly, let's check is our stack empty. So we can see that we don't have any values in our stack. So it means our stack is empty. So since our stack is empty, so we don't have any top value to compare with, right? So what we will do is we will simply put this particular closing bracket in our stack. So we'll put this closing bracket and its index, fine. Now we'll move forward. So we have got an opening bracket. So whenever we get an opening bracket, we simply push it in the stack along with its index, correct? Now we will move forward. Now we have got a letter, we'll ignore it. Now we have got an opening bracket. So whenever we get an opening bracket, we similarly push it along with its index, correct? Now we will move forward. We have got a letter, we'll ignore it. We'll move forward. We have got a closing bracket. So whenever we get a closing bracket, what we do? We first check, is our stack empty? So stack is not empty. Then we'll check what is the top value. So this is our top value, correct? Now, is that top value our opening bracket? So we can see that our top value is an opening bracket. So what we will do is we will remove this value, indicating that for this particular opening bracket, that is for this particular opening bracket, we have found the closing bracket, which is this one, correct? And these two are forming a valid pair of parentheses. So we don't need to store them in the invalid stack, correct? So what we will do is we will pop it, fine? And we'll move forward. Now we can see that we have completely processed all the values of our string S. So what does it mean? It means that these brackets and its index, corresponding index, which is remaining in the stack, represent the invalid parenthesis. That is the parenthesis because of which this particular string is an invalid parenthesis string, right? So let's see which are those parentheses. So we can see that it's an opening parenthesis at the 10th index. So where is the opening parenthesis? So this is the opening parenthesis at the 10th index, correct? And the another value is the closing parenthesis at the 9th index. So we can see that at the 9th index, we have this closing parenthesis. So it means that because of these two parentheses, this particular string S is a invalid parenthesis string. So what we have to do is we have to remove it. So let's see now how we can remove it. So we are done with the first step. So what was our first step? Our first step was to identify invalid parenthesis, correct? Now we have identified that at the 9th index and at the 10th index, we have invalid parenthesis. Now what is the second step? The second step is to remove it, correct? Now let's see how we can remove it. Now in order to remove it, what we can do is we can take a hash map, and what we will do in the hash map is we will iterate over the stack. That is, we will say that until the stack is not empty, what we will do is, let's say that this hash map will store integer, and corresponding to it, it will store a Boolean value. Now, what does this integer represent? This integer represent the index. And what does this Boolean represent? Boolean represent, let's say it's represent is present, correct? So, this represent that whether this index is present in the stack or not, correct? So, what we will do is we will process the first value of the stack. So, what is the first value of stack? This is the first value of stack. So, what is its second value? The second value is 10, right? That is the index is 10. So, what we will store is we will store the index 10 and we will mark true, indicating that this particular index is present in the invalid stack, correct? And we will pop this. Now, what is the next value? The next value is this one. And what is the index? The index is 9. So what we will do, we will store this 9 in the hash map and we'll mark true corresponding to it, indicating that the parenthesis present at the 9th index is an invalid parenthesis and it is present in the invalid stack. Correct? Now we have marked that which all indices are invalid. Now what we have to do? Now we will take an empty string answer, and what this answer will store? This answer will store the final string s, that is after removing the invalid parenthesis. Correct? So what we will do in order to populate answer is, we will iterate over this particular string s, right? And we will check that whether this particular index is present in the hash map or not. Correct? If a particular index is present in a hash map, then what does it mean? It means that parenthesis present at that particular index is an invalid parenthesis, and we should not add it to our answer. Correct? So let's see how we will do it. We are present at the 0th index. We'll check, is the 0th index present in the hash map? No. So what we'll do, we will add L. Now we'll move forward. We'll check, is the first index present in our hash map? No. So we will add this opening bracket. Then we'll move forward. We have got a E. Now we'll check that is the second index present. Second index is also not present in hash map. So we will add this E. Now we will move forward. So we have got the third index. We'll check, is this third index present in the hash map? So it's not present. So we will add this closing bracket. Okay. Now we'll move forward. So we are at the fourth index. Now we can also see that this fourth index is also not present in the hash map. So it means that it is valid. So we will add this E. Now we'll move forward. This fifth index is also not present in the hash map. So we will add it to our answer. Now we'll move forward. Sixth index is also not present. We'll add it. Move forward. Seventh index is not present. We'll add it. Move forward. Eighth index is also not present. We will add it. We'll move forward. We are at the ninth index. Now we'll check that is this ninth index present in the hash map. So we can see that the ninth index is present in the hash map. So what does it mean? It means that the parenthesis present at the ninth index is an invalid parenthesis. And because of this particular parenthesis, this string S is not a valid parenthesis string, right? And we want to make this string a valid parenthesis string. So what we need to do? We need to remove it. So what we will do in order to remove it? We won't add it to our answer. Simply we won't add it to our answer and we'll move forward, correct? Now we are at the 10th index. Now we can see that the 10th index also exists in the hash map. So what does it mean? It means that the parenthesis present at the 10th index is an invalid parenthesis, correct? And because of this parenthesis, the particular string S is an invalid parenthesis string. And in order to make it valid parenthesis string, what we will do? We won't add this to our answer, correct? And we'll simply move forward. Now we are at the 11th index. We can see that 11th index is not present in hash map. So what we will do? We will add this T. We'll move forward. 12th index doesn't exist in hash map. We will add it. Move forward. 13th index doesn't exist in hash map. We will add it. We'll move forward. 14th index doesn't exist in the hash map. So we'll add this one. So, and we'll move forward. Now we can see that we have completely processed all the elements of the string S. So what does it mean? It means that we have got our answer and this is the answer. And we can also see that in the answer, all the pair of parentheses are valid. Like we can see that for this opening bracket, we have a closing bracket. For this opening bracket, we have a closing bracket. For this opening bracket, we have a closing bracket, right? So this is now a valid parenthesis string. So this is the first approach. Now let's quickly recall what we are doing in the first approach. In the first approach, we will be first iterating over the string S. And whenever we'll get an opening bracket, we will add it along with its index in the stack, correct? And whenever we'll get a closing bracket, what we will do, we will check that if the top value is an opening bracket, then we will pop it. Otherwise, if the top value is not an opening bracket or if our stack is empty, then what we'll do, we'll add the closing bracket along with its index. Fine. Now, after populating the stack, what we will do? Now, the values in the stack represent the set of invalid parentheses, correct? And we need to delete it. So, how we will know that what is the index of them? So for that purpose, we are maintaining a hash map in which we will store its index, and corresponding to that, we'll mark true, indicating that the value present at these index are invalid and we don't want to add it, correct? And after that, what we'll do, we'll take an empty string answer, which would be our final answer, and we will populate it by simply iterating over the string S, and we will check whether that particular index exists in the hash map or not. If it doesn't exist in the hash map, we will add it to our answer. If it exists in the hash map, then what does it mean? It means that the parenthesis present at that particular index is an invalid parenthesis, and we won't add it. We'll simply ignore it and move forward, correct? So let's quickly code this. So first of all, we'll create a stack, and its type would be pair of character, comma, int, correct? Let's call it as stk stack. And what we will store the element and its corresponding index, correct? Now, what we have to do, the first step is to identify the invalid parenthesis. And in order to identify the invalid parenthesis, what we will do, we will first iterate over the given string S. So we'll say index equals to 0, index less than S dot size, index plus plus. Now, if it is an opening bracket, correct? That is, if the value present at s of index is an opening bracket, then what we will do? We'll simply push it in our stack along with its index, correct? So we will add s of index and its corresponding index in the stack, correct? Now, else if it is a closing bracket, so what we have to do? If it is a closing bracket, then we have two cases. The first case is that if our stack is not empty and if the top value of the stack, that is the top dot first value of the stack. Now, why I am writing top dot first? Let's say the top value in our stack is opening bracket, okay, and its particular index is 0, okay. Then if I do stack dot top, what I'll get? I'll get this entire thing, correct? That is, I'll get this entire pair. But what I want only the first part, right? That is, I want to compare it only with the bracket. So for that reason, we have written dot first, correct? If it is equal to an opening bracket, correct? Then what does it mean? It means that the closing bracket which we have got, for that an opening bracket exists. So what we will do, since it is a valid pair, we will pop it, because we are only storing the invalid pairs in the stack, correct? So since it is a valid pair, we will pop it. Now, else what will happen? The else case could be that the stack is empty and we have got a closing bracket. So what does it mean? It means that we don't have any top value to compare with. So what we will do in the stack, we will simply add the particular closing bracket and its corresponding index, correct? Or the other case could be that the top value is a closing bracket only. So we have got a closing bracket and the top value is also a closing bracket. So it means that for that particular closing bracket, we have not got an opening bracket. So we'll simply add it, correct? Now, the moment we will come out of this for loop, what will happen? The stack would be containing all the invalid pairs, correct? So what is the first step? The first step is to identify invalid parenthesis, correct? So the moment we'll come out of this for loop, we have already identified the invalid parenthesis. Now what we will do? Now we have discussed that we will take an unordered map of type int, comma, boolean. Let's call it as memo. And what we will store? We will store the index, and corresponding to it, we will store either true or false, correct? Indicating that whether it's present in the stack or not, correct? Now what we will do? Now we will iterate over the stack. That is, we will say that while our stack is not empty, what we have to do is, we will say that memo of stack dot top. Now, if I do stack dot top, what I'll get? I'll get this entire thing. That is this one, correct? But what I want only the index. So what is the index? Index is the second value. So we'll say stack dot top dot second, correct? And I'll mark it as true, indicating that this particular index is present in the stack, right? That this is an invalid index, correct? And since I have already added the index for this pair, so I'll simply pop it, correct? Now we will come out of this while loop. Now what I have to do? Now I have to populate our answer. So we will take a string answer, which would be initially an empty string, and we have to populate it. How we'll do? We will iterate over the given string s. So we'll say index equals to 0, index less than s dot size, index plus plus, correct? And after that, what we will do? We will check if memo of index is false, correct? Then what we will do? Then we will add it to our answer, correct? Because what does it mean? If memo of index is false, then it means that this particular index is not present in the hash map. And when is an index not present in a hash map? An index would be not present in the hash map only if it was not present in the stack, correct? And if an index is not present in the stack, then what does it mean? It means that all the value present at that index is a valid element, correct? And if we will add that particular element in our answer will still remain a valid parenthesis string, correct? So we will check that if the value is not true, then only add it to our answer, correct? And what we will do, we'll finally return our answer. Fine. Now let's quickly run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity of this approach. So if we consider the size of the given string as n, then the total time complexity would be order of n. Let's see how. So here what we are doing, we are iterating over the entire string s in order to find out that which are the invalid parentheses, correct? So we will be processing all the n elements. Therefore, this for loop is going to cost us a time complexity of order of n, correct? Now coming over here, we are having a while loop. And say in the worst case, let's say that we have a string which is containing all the closing bracket, correct? Then this entire string is invalid, fine, because for all these closing bracket, there is no existing opening bracket. So in this case, when all the parentheses present in the string is invalid, correct? And the entire length of the string is consumed only with the parentheses, then what would be the size of the stack? The size of the stack in that particular case would be n, correct? Why? Because it will be having all the n elements in it. So it means that in that case, this while loop will run for an order of n time complexity, correct? And now again over here, what we are doing, we are iterating over the entire element of string s in order to populate our answer. So this will cost us order of n again. So order of n plus order of n plus order of n will give us order of 3, and since 3 is the constant, we can ignore it, so we'll get a time complexity of order of n. Now coming to the space complexity. So what we are doing, firstly we are using a stack, and as we discussed, we can have a case in which all the elements of the given string are parentheses, such that let's consider all of them is a closing parenthesis. So all of these are invalid. So what will happen? This particular stack will contain all the n entries, correct? So it means that the space complexity that this stack will consume would be order of n. Additionally, we are using a hash map over here. So this hash map will also have n entries in it. So the space complexity would be order of n plus order of n, that is order of 2n. Since 2 is the constant, we can ignore it. So the space complexity is order of n. Now let's see, can we have a better approach than this? So what we were doing in this particular solution, we were using a hash map and the stack, so that the stack was containing a pair of character and int. So let's see, can we solve this problem without using this hash map? So let's discuss the approach 2 quickly. Now what we will do in the second approach, we will use the stack in order to keep track of the invalid indices. That is, in order to keep track of the indices of the invalid parentheses, correct? So since we are having this letter, so what we will do is we will ignore it, correct? Now we are over here, that is we are at the opening bracket. So whenever we'll get an opening bracket, what we will do is we will store its index in the stack. So we have stored its index in the stack, and this is the top value, and we'll move forward. Now we have got a letter, we'll ignore it, we'll move forward. Now we have got a closing bracket. Now we'll check whether our stack is empty or not. So we can see that our stack is not empty. So what does it mean? It means that for this particular closing bracket, there exists an opening bracket. So what do we will do? We will remove this from the stack. Why? Because in the stack, we are only storing the invalid parenthesis, correct? But for this particular opening bracket, that is for this opening bracket, we have found out a closing bracket. So what does it mean? It means that these are a valid pair of parentheses. And if we will add it to this string s, that is if it would be present in the string s, it won't make it invalid, correct? So we'll simply move forward. We have got a letter, we'll ignore it, we'll move forward. Now we have got an opening bracket. So what we will do, we will store its index in the stack. So we have stored the index 5, correct? We'll move forward. We have got a letter, we'll ignore it, we'll move forward. We have got a letter, we'll ignore it, we'll move forward. We have got a closing bracket. Now we'll check, is our stack empty? So we can see that our stack is not empty, correct? So what does it mean? It means that for this particular closing bracket, there exists an opening bracket and they will form a pair of valid parentheses. So since this particular opening bracket found a closing bracket, so it means that it is not an invalid parenthesis. So we will pop it from the stack and we will move forward. Now what we have got? We have encountered a closing bracket. Now we'll check, is our stack empty? So we can see that our stack is empty. What does it mean? It means that for this particular closing bracket, we haven't encountered any opening bracket in this string up till now. Because let's say if I'll give you a string like this. Now tell me it is a valid parenthesis string or not. So you say it is not a valid parenthesis string. Why? Because for this particular closing bracket, there is no opening bracket, right? Similarly, we can see that we have this opening bracket, but for this opening bracket, this is the closing bracket. And for this opening bracket, this is the closing bracket. But for this closing bracket, we have not got any opening bracket till now, right? And because of that, only the stack is empty. Because if the stack is empty, then what does it mean? It means that we have not got an opening bracket. That's why the stack is empty, right? So since for this particular closing bracket, we don't have an opening bracket, what we will do is, we need to remove it, correct? We need to remove it in order to make this particular string as a valid parenthesis string. So what we will do is, we will replace it with something else. Now, what do I mean by something else? Now, can we replace it with alphabet? The answer is no. Why? Because this string S already contains alphabet and we want to uniquely identify this place, right? Because we want to know that, yes, this is the place where an invalid parenthesis is present, correct? Now, can I replace it with some other parenthesis? The answer is no, correct? Now, what I'll do is, I'll replace it with an asterisk. You can replace it with a plus, minus, divide sign, dollar sign, or whatever you like, correct? Why? Because we know that this particular sign will never be present in this string S, because we know that this string S contains only opening parenthesis, closing parenthesis, and alphabets. So if I replace this particular closing parenthesis with an asterisk, then what does it mean? It simply means that this particular element was an invalid parenthesis. That's why we have replaced it with an asterisk, right? So we have replaced it with asterisk in order to mark this particular place, that this place was having an invalid parenthesis and we don't have to add this in string S, correct? And we'll move forward. Now we have got an opening bracket. So what we will do, we will add its index to our stack. So we will add 10 to stack and we'll move forward. We have got a letter. What we'll do, we'll ignore it and we'll move forward. Now we are at the 12th index and it's an opening bracket. So what we will do, since we have got an opening bracket, we will add its index and we will move forward. Now we are at and letter. So we will ignore it and we'll move forward. Now we have got a closing bracket. Now whenever we get a closing bracket, what we do, we check whether our stack is empty or not. So we can see that our stack is not empty. It's having some of the elements in it. So what does it mean? It means that for this particular closing bracket, we have an opening bracket. And where is that opening bracket? That opening bracket is present at the 12th index. That is, this is the opening bracket. So it means that these two are forming a pair of valid parentheses, correct? So it means that if I'll add these two to our string S, it will still remain a valid parenthesis string. So what we will do is, since this opening bracket, that is the opening bracket present at the 12th index, is the valid parenthesis, so we will simply pop it out from the stack, because in the stack we are only storing the invalid parenthesis, and we'll move forward. So we have completely processed all the elements of the string S. So what does it mean? It means that we have marked the closing bracket which was invalid as a asterisk. Now we can see that still we are having some element in the stack. So what does it mean? It means that what we used to store in the stack, we used to store only the opening bracket in the stack, right? So if there is an element in the stack, so it simply means that for this particular opening bracket, that is the opening bracket present at the 10th index, that is this one, for this opening bracket, we have not encountered any closing bracket. Additionally, you can also see that for this opening bracket, this is the closing bracket. For this opening bracket, this is the closing bracket. For this opening bracket, this is the closing bracket. For this opening bracket, we don't have a closing bracket. So what does it mean? It means that this is an invalid parenthesis. So because of this parenthesis, our string is an invalid parenthesis string. So what we have to do? We have to remove it. So in order to mark this place, what I'll do is, I'll simply mark it as an asterisk, representing that the parenthesis present at this place, that is at this 10th index, was invalid and we don't need to add it to our answer, correct? Now what we will do, we will take a string answer which would be initially empty. And after that, what we'll do, we'll iterate over the string S in order to populate this answer. And we would be initially present at the 0th index. We will check that is the element present at the 0th index an asterisk. Why we will check whether it's an asterisk or not? Because we marked all the invalid parentheses with an asterisk, right? So we will need to check that if we get an asterisk, then we don't have to add it to answer, right? So we can see that this is not an asterisk, so we will add it to answer. We'll move forward. This is not asterisk, we will add it to our answer, we'll move forward. This is not asterisk, we'll move it to our answer, we'll move forward. This is also not asterisk, we'll add it to our answer, we'll move forward. Not an asterisk, we'll add it, we'll move forward. Not an asterisk, we'll add it, we'll move forward. This is not an asterisk, we will add it, we'll move forward. C is over here, that is it's not an asterisk, we'll add it, we'll move forward. This is also not an asterisk, we'll add it, we'll move forward. Now we can see that the element at the 9th index is an asterisk. So what does it mean? It simply indicates that whatever parenthesis we earlier had at the 9th index was an invalid parenthesis, and because of that parenthesis, this string S was an invalid parenthesis string. So we don't have to add this particular element. So we'll simply move forward. Similarly, we can see that at the 10th index also we have an asterisk. So we will ignore it and we'll move forward. Then at the 11th index, we don't have an asterisk. So we'll add it, we'll move forward. 12th index, we don't have asterisk, we'll add it, we'll move forward. 13th index, no asterisk, we'll add it, we'll move forward. At the 14th index, we don't have an asterisk, we'll add it, we'll move forward. We can see that we have completely processed the string S. So what does it mean? This is the given answer and this is a valid parenthesis string. So this is how we'll be solving this problem using the second approach, correct? So let's quickly code this. So we will start on by creating a stack of type int, and what we will store in this, we will store the index of opening bracket, correct? Now what we will do, we will iterate over this given string S. So now what we will do, we will say that if the element present at S of index, if it is an opening bracket, then what we will do, we will simply push its index to the stack, correct? So we will push the index, fine. Otherwise, if it is a closing bracket, then what do we need to do? If it is a closing bracket, then we first need to check if our stack is empty or not, correct? So if we will find out that our stack is empty, then what does it mean? It means that for this particular closing bracket, we have not encountered any opening bracket, fine. So it simply means that this is an invalid string, right? So what we will do is, since this is an invalid parenthesis, we will remove it. That is, we will replace it with some other character in order to uniquely identify it, correct? So what we will do is, we will set S of index as an asterisk, correct? Else, what we can have is that the stack is not empty. So if the stack is not empty, then what does it mean? It means that for this particular closing bracket, there exists an opening bracket. So it means that that opening bracket and this closing bracket are forming a pair of valid parentheses. So what we will do, we will simply remove that particular opening bracket from the stack, because what we are storing in the stack, we are only storing the invalid opening bracket, correct? We will set S of stack.top as an asterisk, because if this particular index is present in our stack, then what does it mean? It means that for this particular opening bracket, we have not encountered any closing bracket. That's the reason only why it is present in our stack, right? Because if we would have encountered a closing bracket for it, then it would have already been removed from the stack, right? Now, after adding this, what we will do, we'll simply say stack.pop. The moment we'll come out of this while loop, what will happen? till this step, what we have done, we have identified, or we can say that we have marked invalid parenthesis with asterisk, correct? Now what we have to do, now we have to only populate our answer. So let's take a string answer, which would be initially empty. And what we will do is we will iterate over the given string. So what we will do, we'll say that if s of index is not an asterisk, correct, then only add it to our answer. So we'll say answer plus equal to s of index, correct? Now what we'll do, we'll simply return answer. So let's quickly run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity. So if we have n as the size of the given string, then the time complexity would be order of n. Let's see how. So we can see over here that what we are doing. Over here, we are iterating over all the elements of the string s, correct? So it means that we will be processing all the n elements. So this for loop is going to cost us a time complexity of order of n, correct? Now coming to this while. Now we can have a string s such that it's containing only the opening brackets, correct? So what will happen is we will end up storing all these opening brackets in the stack, correct? So what will happen is this while loop will run order of n number of times, correct? Because we will be storing all these opening bracket in it. So it will run for order of n time complexity, correct? And over here, we can see that we are again iterating over the given string s. So it will cost us order of n time complexity. So order of n plus order of n plus order of n will give us order of 3. And since 3 is the constant, so we can ignore it. Therefore, the time complexity is order of n. Now, what would be the space complexity? The space complexity would be order of n as well. Why? Because we are using a stack over here. And what we are storing? In this, we are storing the indices of the invalid opening bracket, correct? And in the worst case, what could happen? All the elements of the string could be an opening bracket. So it means that we will end up storing all the n entries, correct? Therefore, the space complexity is order of n. So this approach is better than the previous approach, because in the previous approach, we were using a hash map as well. Now let's discuss the optimal approach. That is the third approach. Now in the third approach, what we will do is we will firstly identify invalid opening bracket, and after that, we will identify invalid bracket, correct? Now let's see how we can do it. So first of all, we'll start on by creating a variable. Let's say the variable is open. So it would be initially 0. Now what does this variable represent? This variable represents the count of the opening bracket that we have encountered till now, correct? Now we are present over here. Since this is a letter, what we will do, we'll simply ignore it. Now we are at the first index. Now we have got an opening bracket. So what we will do, we will increment the count of the opening bracket, indicating that we have got an opening bracket. So what we did that if s of I is an opening bracket, then what we are doing, we are simply incrementing the count of the opening bracket. That is, we are doing open plus plus. Fine. Now we'll move forward. This is the letter. So what we'll do, we'll ignore it. We'll move forward. Now we have got a closing bracket. Now whenever we'll get a closing bracket, what we will check? We will check that if our s of I is a closing bracket, then what we will do? We will check that if our open is 0. If it is 0, we'll do something. If it is not 0, we'll do something else. Correct? Now let's discuss what we'll do. Now initially what we have, we don't have open as 0. Correct? What does it mean? That the opening bracket count is not 0. So what it means? So it simply means that for this particular closing bracket, there exists an opening bracket, right? Because the opening count is not 0, right? So it simply means that for this closing bracket, there is an opening bracket. So what we will do is, since this closing bracket and this opening bracket is forming a pair of valid parentheses, so what we will do is we'll subtract 1 from this count. So it will get decremented by 1 and we'll get 0. And we'll move forward. We have got a e, we'll ignore and move forward. We have got an opening bracket. So what we'll do, we'll increment the count of this open. So we have got a 1. We'll move forward. We have got a T, we'll ignore it. We have got a C, we'll ignore it. We have got a closing bracket. Since we have got a closing bracket, we'll check whether this open count is 0 or not. So we can see that open count is not 0. So what does it mean? It simply means that for this closing bracket, there exists an opening bracket and they are forming a valid pair. So since this opening bracket contributing to form a valid pair with this closing bracket, so what we will do, we'll decrement 1 and we'll get a 0 and we'll move forward. So we have encountered a closing bracket. We'll check, is our opening bracket count 0 or not? So we can see it is 0. So what does it mean? It means that for this closing bracket, there doesn't exist any opening bracket, because we can see that for this closing bracket, this was the opening bracket. For this closing bracket, this was the opening bracket. And for this closing bracket, we don't have any opening bracket, right? So what does it mean whenever open is 0? Whenever open is 0, it means that this is an invalid closing bracket. So what we will do, since this is an invalid closing bracket, we will mark it with asterisk so as to identify it, correct? And we will move forward. Now we have got an opening bracket. Since we have got an opening bracket, what we'll do, we'll increment its count. Now we'll move forward. Letter, ignore it. We have got an opening bracket, we will increment the count of opening bracket. So it will become 2. We have got a e, we'll ignore it. We have got a closing bracket. Since we have got a closing bracket, what we will do is, we will see is the open bracket count 0. So we can see that open bracket count is not 0. So what does it mean? It simply means that for this closing bracket, there exists an opening bracket. And since this particular opening bracket is contributing to form a valid pair with this closing bracket, so what we will do? We'll decrement 1 from over here. So what we'll get? We'll get 1 and we'll move forward. Now we can see that we have completely processed all the elements of string S and we have identified all the invalid closing brackets, correct? Because we identified that this particular closing bracket was invalid. But you will say that we have not yet identified the invalid opening bracket, right? So how are we going to do it? So don't worry, we'll be following the same step but in a little bit reverse order in order to find out the invalid opening bracket. So let's now identify the invalid opening bracket. And additionally, I would like to point out one more thing is that you have seen that we have completely processed all the elements of the string S, but this open count is still not 0, right? So what does it mean? It is 1. So it means that in this particular string S, there exists a opening bracket which doesn't has a closing bracket, correct? Because if it would have a closing bracket, then what we would have done? We would have decremented it by 1 and it would have become 0, right? But it's not 0. So it simply means that we have one closing bracket in this particular string S that doesn't has a closing bracket, correct? So let's see how we can now identify the invalid opening bracket. Now for identifying the invalid opening bracket, what we will do, we will take a variable, let's say close, which would be 0. And what it would do is, it will keep track of the count of the closing bracket, correct? And we will start iterating from the end. Fine, we'll move like this, correct? Now what we will do is, we have got a closing bracket. So what we will do, we will increment its count. So it would become 1. So what does it mean? It means that if we have encountered a closing bracket, what we are doing, we are now incrementing close, correct? Now, what we will do, we'll move backward. So we have got a letter, we'll ignore it. Now we have got an opening bracket. Now we'll see that what is the value of close. So the value of close is 1. It means it's not 0. So what does it mean? It means that for this particular opening bracket, we have a closing bracket. So since this closing bracket is contributing to form a valid pair with this particular opening bracket, so what we will do, we'll decrement the count of close by 1, indicating that a closing bracket is forming a valid pair with this opening bracket, correct? And then we'll move backward. We have got a D, it's a letter, we'll ignore and move forward. Since we have got an opening bracket, what we will do, we'll check what is the value of close. So we can see that the value of close is 0. So what does it mean? It means that for this particular opening bracket, we don't have any closing bracket, correct? Because we had only one closing bracket over here and it is forming a pair with this opening bracket. And for this particular opening bracket, we don't have a closing bracket. That's the reason why this close count is 0, right? So we need to identify this. And how we will identify this? We'll replace it with an asterisk. So what we are doing? We are removing all the invalid parentheses with asterisk. And we'll move backward. So since this is a asterisk, we'll ignore it. We'll move backward. We have got a closing bracket. So we'll increment the count of close. It would become 1. We'll move backward. We have got a C, ignore, move backward. We have got a T, ignore, move backward. We have got a opening bracket. Now we'll check what is the count of close. So we can see that the count of close is 1, right? What does it indicate? It means that for this particular opening bracket, there exists a closing bracket and they are forming a valid pair. So we will decrement 1 from over here, we'll get a 0 and we'll move backward. We have got a letter, ignore it, we'll move backward. We have got a closing bracket, so we will increment the count, it would be 1. We have got a letter, ignore it. We have got an opening bracket. Now we'll check, is close 0? So close it not 0. So what does it mean? It means for this opening bracket, there exists a closing bracket and these two are forming a valid pair. So it means that this particular closing bracket is contributing to form a valid pair. So what we'll do, we'll subtract 1 from here, we'll get 0. We'll move backward. We have got L. We'll ignore and move backward. Now we can see that we have completely processed all the elements of S and we can see that we have successfully identified the invalid opening bracket, correct? So firstly, what we did, we identified the invalid closing bracket and after that, what we did, we identified the invalid opening bracket, correct? And after identifying invalid opening and invalid closing bracket, what we'll do, we'll simply iterate over this given string S and we will check that if the current character is not an asterisk, we'll add it to answer. So I hope this solution is clear to you all. So let's quickly code this. So initially we'll take a variable, let's say open. So what this open will do, this open will keep track of the count of the opening bracket that we have encountered, correct? Now what we will do, we will iterate over the given string. What we'll say that if S of index is an opening bracket, then what does it mean? It means that we'll simply increment the count of the opening bracket, correct? Else if what we can have that S of index is a closing bracket. Now if it is a closing bracket, what we need to check? We need to check if this open count is 0. If this open count is 0, then what does it mean? It simply means that for this particular closing bracket, there does not exist an opening bracket. So this closing bracket is an invalid closing bracket. So what we will do? We will replace it with an asterisk. And why are we replacing it with an asterisk? In order to mark it as invalid, correct? Else what we will do? Else what does it mean? Else if the count of the open is not 0, then what does it mean? It means that for this particular closing bracket, there exists an opening bracket. So it is forming a pair with that opening bracket. So we'll simply decrement the count of open. So we will say that open minus minus, correct? Now the moment we'll come out of this while loop, what we would have done? We would have successfully identified the invalid closing bracket, right? Now what we have to do? Now we have to identify invalid opening bracket, correct? Now for that, what we'll do? We will iterate over the given string starting from the end. We'll say that if the value present as s of index is a closing bracket, then what we have to do? We'll simply increment the count of close, correct? And let me also take the variable close over here. So we'll take close as 0, correct? And otherwise, what could be the case? The other case could be that s of index is an opening bracket. So if s of index is an opening bracket, then what we need to check? We need to check that if our close is 0, then what does it mean? It means for this particular opening bracket, there does not exist any closing bracket. So it simply means that this opening bracket is invalid. So what we will do? We will mark this opening bracket as invalid. So we will replace it with asterisk, correct? Otherwise, if this close count is not 0, then what does it mean? It simply means that for this opening bracket, there exists a closing bracket. So what we will do? We'll say close minus minus, correct? And the moment we'll come out of this for loop, what we will have done? We would have successfully identified all the invalid opening bracket. Now what we need to do? Now we simply need to populate our answer. So we'll say string answer. Initially, it would be an empty string. And what we will do? We'll simply iterate over the given string s. So we'll say auto current is to s. We will say that if current is not an asterisk, then simply add it to our answer, right? Answer plus equals to correct. And finally, what we will do? Finally, we will return our answer, correct? Now, this is the entire code. Let's quickly run this. So it is giving the correct answer. Let's submit it. And it got accepted. Now, talking about the time complexity and space complexity. If we consider n as the size of the given string s, then the time complexity would be order of n. Let's see how. So what we are doing over here? Over here, we are iterating over the complete string s in order to identify the invalid closing bracket, correct? So it means that we will be processing all the n elements, fine. And what we are doing over here? Over here, again, we are iterating over the entire string s in order to find out the invalid opening bracket. So we'll be processing all the n elements. And over here, again, we are iterating over all the elements of s. So it would be order of n plus order of n plus order of n, which will give us order of 3. And so since 3 is the constant, we can ignore it and we'll get order of n as the time complexity. And talking about the space complexity, so here we can clearly see we are not using any extra space. So the space complexity is order of 1. And this is the most optimal solution. So that's all about today's Daily LeetCode challenge.